In this lesson we will discuss engraving operations. At first, it seems that engraving operations can be done effectively using Cuttin Curve strategy, and indeed they can under some circumstances. Engraving strategy, however, is truly meant for engraving on all sorts of surfaces, and we will see how these two differ. But first, let's look at a case, the one and only case, where Cuttin Curve and engraving strategies overlap. And that is a flat surface that can be reached perpendicularly with a bit. So here's our model. We have some sort of set of curves lying on the surface of the model, and if we select Cuttin Curve, specify our viewport, so we're cutting from, this is our top view down mode, and we select our curves, press enter, and specifying a depth of 0.5 millimeter, we click calculate, and we see that our toolpath will be cut a depth of 0.5 mil underneath, tracing these letters. In our simulation window, let's switch to workpiece view mode, and it does pretty much exactly what you expect it to. Cuts it out just like so, from top down. If we perform the same operation, but now using engraving strategy, selecting the same curves, oops, let me try it again. I think I've selected a few more curves than necessary. Here, specify the same depth, 0.5, and we'll see that there's our second strategy. It's the same thing. Likewise in the simulator, we will see that it does exactly the same thing. So on first glance, it looks like these strategies kind of overlap, and they do, well, as I mentioned, only in this circumstance. Each has its own specialties that you can use to take it in different directions. Cuttin Curve allows you to, in addition to cutting from top down, to cut at an angle, any angle you wish. And you do that by specifying a vector or an orientation line for every curve that you're cutting. So for example, you have your letter E, which is a single curve, and instead of cutting it top down, let's say you want to cut it at an angle, like so. You can do so by selecting the single letter, single curve, specifying Cuttin Curve, and then within the operation, let's first of all look at how it will be by default. There's our engraving 0.5 millimeter underneath. But now let's specify orientation line. We can see our implicit line, which is just going straight down. We'll unselect it and select our new vector, press enter, and recalculate. Now you'll see that our engraving has shifted. It's tilted slightly upwards, and in our simulation you'll notice right away that our a-axis is no longer at 90 degrees but now at 122. Switch back to our mode of workpiece stock viewing and let it cut, and now you'll see that this angle of entry is different too in this simulation, and we've cut out this E at an angle. So you could do it for the rest of the letters, including letters composed of, for example, multiple curves. The only catch is that you do have to specify a vector or orientation line for every curve. So if you just specify this for letter T, you will get an error because JewelryCam will not know how to cut this line. It does not have a default that it reverts to. So we have to add one for every curve segment. So now let's select this group, go to Cuttin Curve, press enter, and orientation lines, we will take out the default and say I want to use this line and this line as your directions. Click recalculate, and see the funny squiggles underneath that are indicating how those two curves will be cut. So that is one ability of Cuttin Curve that engraving does not have. We can specify any vector approach, um, allowing us to cut our curves from a very precise way. And this is in addition to being able to repeat our cut. As you recall, there's both the number of layers and the depth between each layer that we can use. Finally, one more operation or option for the Cuttin Curve that we haven't discussed yet is the ability to use stock definition. So let's choose all of these lines again as before. Oops, make sure to do that again. As our viewport, and select these lines here. I'll get rid of these orientation lines for now, and recalculate. So we get our default cut of 0.5 mil underneath. And now, let's say this is the first operation you're doing. You haven't removed any of the stock on the outside, and you have a fairly large box of wax around this whole thing. Well, you can also tick off this option that says use stock definition, which means it will take into account that there's other material above this. And that's the material that is specified in your stock initially when selecting the model. Now, when you recalculate, it will make multiple layers, as many layers as necessary to reach your final depth. If we go to our ghosted mode, you'll see that it still reaches our desired depth of 0.5 mil underneath the surface, but now it has also added all of these extras so that the tool does not plunge all the way down here, but it goes step by step by step, thereby making a nice clean cut. Another useful option potentially for the situations where you are not trimming off the stock to begin with. So, having covered that, let's look at our engraving strategy. As you might recall, initially it looks very similar, especially on flat, easy surfaces like this. Choose engraving, press enter, options look otherwise normal, and we produce something like this. Well, in order to see the full power of the engraving strategy, we have to examine a case where we're not dealing with a simple straight surface like this. Let's look at a slightly more complex model. Here we have this squash sphere, and on the squash sphere I projected a number of curves. I intentionally made a number of them so that we can cover various angles rather than just one. So let's perform the same engraving operation on all of these, with the exception of this isocurve. Press enter, and we'll set the engraving depth at 0.5. Looking in our ghosted mode, we see that our engraving lines are 0.5 mil underneath surface as before, but notice that they're now following the object. So as it curves, they curve too. And if we look at our simulator, here it might be worthwhile to make our stock transparent and our workpiece visible. Have a look at these angles as the cutting is being performed. Notice that all of the axes are engaged and the tooltip is staying at all times perpendicular or normal to the surface. So instead of simply following the lines as they're drawn kind of flat, it's using the surface underneath as a guide. The idea is to end up with an engraving that adheres to the surface without having to actually produce these lines or as geometries and boolean them or anything like that. It simply says follow the lines and follow the surfaces, and that's all achieved through this option. So that's your normal to surface engraving. Really the best way to do cleanest engraving, but unfortunately you don't always have the opportunity to do that, to give the machine free rein at being able to access your model from all angles. Sometimes you have to restrict it and direct it to do a cut a certain way, from a certain perspective, for example, or a certain angle. And Jewelry Cam allows you to do that too. For example, instead of being able to turn this model every which way, let's say you can only do your engraving from this perspective. As you can see, this will be able to reach some, but not all the engravings perfectly, but nonetheless, sometimes it's a restriction. So let's set our construction plane to this view, and instead of doing normal to surface, we'll set fixed direction, press set button, and select our viewport. Press enter, apply, and recalculate. Now, in our ghosted mode, you'll see that our tool paths have changed a little bit because of that offset. Let's see what our simulator says. Now, when we run a simulator, you'll notice that our A and B axes are no longer moving. They are fixed, and the entire operation was done at an angle, a specific angle. We didn't have to define a vector line as we did before with the Cuttin Curve, and we didn't have to define these different angles for every curve segment, or rather for every curve. We simply said this one perspective, use it for all things. Finally, there's a third option that you may find useful as well, and that is rotary around arbitrary axis. In rotary, you get to define both an imaginary rotary axis and an angle with that axis. It's somewhat in between mode between the full control that the mill takes when you do normal to surface and the fixed, which is only one perspective. So let's add an extreme case here. This arbitrary rotary axis that will point like this. Imagine that piece is being held this way, and we'll give it a reign of about 20-degree angle all around it. So we select our vector and we set our angle with axis. We recalculate and see our engraving lines are beneath there. Let's see what happens in the simulator. As the milling goes, you'll see that now there is some movement in the A and B axes, but they all follow this imaginary axis of rotation, going all the way around it, keeping that 20-degree angle tilt that we defined in our properties. Once again, a somewhat arbitrary example, but it just shows you the possibility for cutting at arbitrary angles and arbitrary rotations. When is this useful? Well, perhaps the most common case for jewelry is engraving of inside certain areas where you have a defined surface and you'd like to follow your own virtual axis in engraving it, thereby avoiding any collision with your existing model or perhaps even the stock material. That covers the engraving and jewelry camp.